Hello, and welcome to the Gallery of Graph. And now, here's your host, Will.
Okay, welcome to today's video, guys. Today we're looking at sketching hyperbola, not to be confused with hyperbole, which of course is over-exaggeration. Hyperbola are graphs that follow the general format of y equals a over x minus h plus k. And of course, we always know that a is going to be our dilation factor, because of course everybody knows dilation factor starts with a. And then we have we have h here, and that is going to be horizontal translation factor. And then finally we have k, which is going to be our vertical translations there. Okay? And so with that in mind, now let's go into Desmos and have a look at how this stuff goes. Okay, so now we are, of course, in Desmos, and we can see our beautiful hyperbola graph here. And what we can see, first and foremost, is that a hyperbola graph is a uppy-downy graph, as I like to call it. It's got one that goes up and one that goes down. And the reason for this is because it is a y equals 1 over x. That's our generic baseline hyperbola. And so what does that mean? Well, it means that when x is 1, we get 1 over 1, which is 1. And so that's what we get here for our first point. 1, 1. If we then make x a number bigger than 1, you get a smaller fraction. So 1 over 2 is a half, 1 over 4 is a quarter, etc. So it's going to asymptote towards y equals 0, or the x-intercept there. Similarly, if x gets smaller, right, the y value gets bigger. So for example, 1 over an 8th, which is 0.125, you get 8, because it's basically what is 1 divided by an 8. Well, it's going to be 8 there. And so the number gets bigger as the x gets smaller. And then, of course, it's going to, as it approaches 0 and reaches 0, you're going to be 1 divided by 0, which is undefined. So there's going to be an asymptote at x equals 0 or the y-axis. And so, well, then if x is negative, you get a negative half, a negative a quarter, etc., which is what we see here. And so the negative part of it inverts this left-hand section, making it y equal -1 when you have 1, and then when x equals 2, you get negative a half, etc. And of course, as x gets smaller, approaching 0, the numbers asymptote out to infinity there. And so that is the basics of it. Now let's have a look at what happens with the dilation factor. So dilation factor, of course, is a, and that's the one on the top there. So if you have 1 over x, that's our base graph. If we had 2, for example, we're going to dilate away from both axes because, as you can see, well, now we're just timesing everything by 2. So 2 divided by 2 is -1, whereas before it was 1 divided by -2, which is negative a half. And so that's going to happen on both sides. Similarly, if you have a number that is less than 1, so 0.5 on the top in our Franken fraction here, what you can see is that it gets smaller there. Awesome. So this, I just want to bring up, is the same as having a number on the bottom next to the x, right? That gives us the same equation there. I'll just flash the orange one over the top of it. So you can see that 0.5 over x is the same as 1 over 2x. So when the dilation factor goes down to the bottom, in the case of 1 over 2, it's going to be the same as having a decimal on top of the fraction. So a bit of a mind bender there, but that's how that works. The next thing we've got to look at is now a negative graph there. So if we invert the dilation factor, give us a -1 on the top, well, we get one of these blue graphs here, yeah? And this is the same as if you invert the sign in front of x. So just like before, you can see that now that we've got 1 over -x, that's going to also be negative there. So this is the same as -1 over x. So a negative divided by a positive, of course, is a negative, and a positive divided by a negative is also a negative. So that's why that works there. Then moving on to horizontal translation factor.
Put it in H!
If we say had x plus 1, where h is going to be +1, the graph moves to the left. To the left, to the left. And that's because of our null factor law, which we should all be commonly aware of now. And of course, this means that the asymptote also moves with h. So a positive value of h is a move to the left, which gives us a negative asymptote. So the asymptote is going to translate with h there. So in this case, -1. But if we make it, I don't know, let's say -69.
Nice.
Then we would get -69 as our translation there for both of those. And you can see it's the case there. So then that's negatives done. Moving back to positives now, we have this orange graph when when h is -1, we get a translation of 1 unit to the right in the positive direction. And of course, if you change that to say another number like 21, for example, which of course is 9 plus 10, everybody should know.
21.
The graph moves to the right, that amount, as does the asymptote. And so that is horizontal translations. Positive h value moves to the left, and a negative h value moves to the right, as per every other sort of graph we're looking at here in our series of
The gallery of graph.
And so the final thing we're going to look at is k, which is the vertical translation. And for the vertical translation, we have, well, if k is positive, it goes up. And if k is negative, it goes down. So that one's not too hard to understand, but of course, let's just play around with the settings here. So we'll go 69, and then our asymptote would also have to move up to y equals 69 there.
Nice.
And then that's going to be how that one's done. And of course, when you have a -1, let's do 9 plus 10 again.
21.
Then this is also going to have to be -21 there. And so that is what happens with k. So a positive k value moves the graph and the asymptote up, and a negative value moves the graph down, and also the horizontal asymptote moves down as well.
Oh my god, Will's Tutoring is no longer offering a free trial session! No! Will's Tutoring is still offering a free trial session, and also 3 free cancellations per term for sickness and family emergencies.
Okay, so looking at our first graph here, guys, we have y equals 1 over x plus 1 plus 3 there. So the first thing we're going to look at, of course, is going to be the asymptotes. And so we'll start off with the x asymptote. X asym is going to be, well, h is +1 here, so x is going to be -1 for our asymptote. And for the y asymptote, well, y is going to be 3 because a equals 3. Okay? Go ahead and find our intercepts. Now, that means that we've got to solve for the y-intercept. So y-int, what does x equal at the y-intercept every single time? It is 0, of course, guys. And so from there, we can say that y equals, what's our equation again? 1 over 0 plus 1 plus 3. Cool. And that means that we're going to get y equals 0 plus 1. Very hard question. I think that might actually be 1. So.
Oh my god!
So 1 over 1 plus 3. 1 over 1 is 1, so we get 1 plus 3. That means we get y equals 4. Or, in coordinate form, 0, 4. And then after we've found our y-intercept here, we of course have to find the x-intercept, which there will be one. X-int. What does y equal at the x-intercept, guys? It equals 0, of course. And so 0 is going to be equal to, well, it'll be 1 over, what was our original equation there? X plus 1 plus 3. Okay, cool. And so then, well, the first thing we need to do to get x by itself is minus that 3. So we're going to minus 3 on both sides, leaving us with -3 equals 1 over x plus 1. We can then actually do a swap here, because essentially what we would need to do is we would need to go x plus 1 times that out and then divide by -3. But every mathematician worth their salt knows that, of course, and so we can just do a switcheroo here. So this is going to then become x plus 1 is going to equal a sad Irishman's second favorite fraction, which is going to be negative a turd. And why is it an Irishman's second favorite fraction? Because 2 turds is better than 1, and so an Irishman's favorite fraction is going to be 2 turds. The more you know. Anyway, so we've got that, and then of course we need to minus 1 from both sides.
Hey guys, just going to interrupt the video for a second, but if you are enjoying it, then please consider supporting the channel. Old Willie's maths and memes don't put themselves together, I can tell you that. So if you would want to support my work, then please consider buying me a coffee or donating on PayPal. Additionally, I do have a Patreon where I'm going to be uploading chapter-specific solutions to the problems out of a popular textbook series that rhymes with Lanebridge, if you're in Australia. And so if you want to get that, sign up for the Patreon. And finally, if you would like more bang for your buck, then why not hire The Real Deal by contacting me on Facebook or Instagram or X or YouTube or all of the social medias and organising a free trial session from Will's Tutoring, where you can also get 3 free cancellations per term for sickness and family emergencies. Anyway, like and subscribe to the video. That's the end of the plug. Bye!
So what we're going to get is x equals -1 minus 1 over 3. This means that x is therefore going to equal, well, how many thirds are there in -1? There is -3 over 3 minus 1 over 3, which is going to leave us with -4 over 3, or in coordinate form, that would be -4 over 3, 0. And so that is that. Now we can go ahead and draw our beautiful graph here, guys. So I'm going to leave it so that there's a little bit more room on the left-hand side. That's where most of the action is going on. And then we're going to whack down our axes. Got y and, of course, x there. And then we can put in the asymptotes. So we had y equals 3. So that's going to be 1, 2, 3. We're going to put that right there. And then we also have... the x asymptote, which will be at -1, so it's going to be, and so then that means that we've got x equals -1, y equals 3. We can go ahead and now put down our intercepts, so that is 0, 4, so it's going to be right there, and then also 4 thirds -3, 4 thirds -3. So, and also -4 over 3 or -4 thirds there. So that's going to be, well, if this is -1, -4 thirds over 3 would be 1 1/3. So let's say that's about there. And we can then draw our beautiful hyperbola. So, and that is how we draw a hyperbola. Great!
Look, Marge, you don't know what it's like. I'm the one out there every day putting his ass on the line. And I'm not out of order. You're out of order. The whole freaking system is out of order. You want the truth? You want the truth? You can't handle the truth!
Because when you realize that Will's Tutoring is offering a free trial session, and you can also get 3 free cancellations per term for sickness and family emergencies, you'll know what to do.
Forget it, Marge! It's Chinatown!
Homer, I want you to book a free trial from Will's Tutoring.
Yes, ma'am.
Now, before we finish up for today, the last thing I do want to show you is how to draw one of these unfactorized hyperbola that you may come across. And so what we simply need to do first and foremost is factorize the bottom. So we've got 1 over 3x plus 6, which is a New Zealand's favorite number, of course. Boom! And so 3x plus 6, well, they both have 3 in common, so we're going to go 3, x plus, well, 6 divided by 3 is 2, close brackets. And then we would go ahead and graph this one. So for our translations, the dilation, of course, is going to be a third there. But for our translations, we simply need to just say that h is going to be 2. So therefore, for the x asymptote, x is going to be equal to -2 there. The y asymptote, well, there is no k value here, as you can see. So therefore, y asymptote is still just going to be 0. Y equals 0 there, or on the x-axis. And that means that if it's on the x-axis, there's not going to be any x-intercepts, is there? So we can just go ahead and find the y-intercepts. And at the y-int, what does x equal every single time, guys? It's 0. And so that means that we can say that y equals 1 over 3 bracket 0 plus 2. Y is going to equal 1 over 0 plus 2 is 2, so that's going to be 3 times 2. And of course, 3 times 2 is a New Zealander's favorite number, which is going to be 1 over 6. Boom! So y equals a 6th, or in coordinate form, it would be 0, 1 over 6, or our intercept there. Graphing this one now, we can just go ahead and graph this. Found all of our intercepts and asymptotes. We can go and put down our axes there. And big set of axes. We've got y and we've got x, of course. Now, our only asymptote is at x equals -2. So back that ruler there and go do-do-do-do-do-do. And we get x equals -2 there. And then we've got our hyperbola, which is going to come across like so. And then it's also going to go like so. And then, of course, we need to put that in as 0, 1 over 6. And then that is how you graph a unfactorized hyperbola by firstly factorizing it. So that's the end of the video for today, and I would just like to take the opportunity to say, if you found the video helpful at all, I have a I do run a personal tutoring service, so if that's something that you're interested in, please hit me up. I'm on all the social medias. I'm on Facebook, Instagram, X or Twitter, and YouTube. I also have a Patreon where I'm thinking about doing a series where, now if you're an Australian student, I have a series where I go through all the answers from the textbook that's published by a publisher that rhymes with Lanebridge. Nudge. So if that's something you're interested in, please consider signing up through my Patreon, and I will make videos based on the response to that. But anyway, this is the end of the video. Thanks for watching. Bye!